Okay, we're talking about shifting sinusoids. Sinusoids just means like things that have sine, and things that are like sine, like cosine is even like sine. Yeah, it's a pretty brutal word. So phase shifts. If I just shift this thing over like this, I just shifted it over how far? Well, look where it starts at 0, 0, and then now it starts at pi, so I shifted it pi. And I shifted it to the right. So then how would I write that? I'd write sine of x, except it got shifted to the right, pi. So minus a pi. All right. That's the main idea. Now let's go back and review some stuff. All right, if I know that sine is which letter? Y. Sine's y. Then what's the sign at that point? 1/2. So that means sine of 30 is 1/2. Right? All right. What's cosine of 30 then? Square root of 3 over 2. And how would I get the tangent?
Y over x.
Y over x. That over that. 1/2 over root 3 over 2. 1/2 over root 3 over 2. You see how it's a giant fraction in fractions problem? So then you got to know that that really means 1/2 times 2 over root 3, and then the 2's cancel, so my answer is 1 over root 3. Which you can rationalize if you want to and make it root 3 over 3. Okay, anyway, back to this, the waves. If you're looking at sine going up from 1/2 up to 1, and then it starts dropping less than a half, back down to 0. And then sine goes negative, and it goes from -1/2 all the way down to -1. And then it goes back into from the negatives back up closer and closer to 0. And so sine has the wave back and forth between 0, or between -1 and +1, back and forth. Same thing with cosine. Tangent doesn't do that though. Tangent, the graphs are completely different. We'll talk more about those later. All right, what is the cosine of -2 pi over 3? Well, you got to know where -2 pi over 3 is first to be able to do it. And I could see somebody starting this way and saying, okay, 1 pi over 3 is right here. 2 pi over 3 is right here. There's two things wrong with that. Give me one of the things that's wrong with that.
In the all students take calc category, that's supposed to be positive and there's a negative sign.
Actually, that's okay. You can do the cosine of a negative, just the answer would have to be positive. So the fact there's a negative in there does not change anything. If the answer over here, the sides, had come out to be negative, then you'd have a problem. So that wasn't a problem. But as soon as I said, oh, here's 1/3 pi, 2/3 of a pi, that implies this is 1 whole pi right here, right? That's not pi. What's that spot? That's a 1/2 a pi. So I was all wet right from the beginning. That's not 1/3 of a pi. What is that? That's 1/6 of a pi. What's this? 2/6 of a pi. What's this? 3/6, also known as a 1/2 of a pi. Okay, and then there's another thing wrong. It's supposed to be negative. See? So then it starts here, and where is -2/3 of a pi? Well, first of all, I got to figure out where 1/3 of a pi is. If the whole pi would be going over to here, we know it's going to be less than that, right? 1/3 of the pi would be like here. 2/3 would be like right there. All right, so now do you have a better idea where -2/3 of a pi is? I hope you can tell. So I'm going to count it in 6. 1/6 of a pi, 2/6 of a pi, 3/6 of a pi, 4/6 of a pi is the same as 2/3. Right there. Now there's only one way to make that triangle now. Would you please sketch, you don't have to sketch the whole thing, just sketch where the little triangle would be and what the numbers would be on the sides. Time to engage math brain. You've been working on some other homework, get it away because you need your math brain right now. No, it's been a long day for me too. I'm tired and hot and dehydrated and hungry. And a little frustrated because a lot of kids didn't do their homework, but I can't control that, so. All right. This drops down to here. Then I make my triangle. Then I ask myself, is this right here, is this an angle that I know? Yeah, it is. That's an angle I know. And that angle right there is 60, right? Because the little pointy angle up here, that one's 30. So that means that's a 60-degree angle. Did I just answer the question? Is the answer 60? No, because this is the answer, right? That's 60. I already knew that. I knew that. Well, I could have theoretically known that anyway. But actually, it wouldn't even be 60. It'd be this. But the point is, I don't want the degrees. What do I want? I want this. What is that? What are those supposed to be? Sides. So if this is a 60, then I got to label my sides. 1, 2, square root of 3. Did I do that right? Yeah. Okay. So then I should be able to know what are the sides ratios that go with this. Cosine is adjacent over hypotenuse. What's the adjacent one? That's actually not a 1 though. -1. That's a negative root 3. So the cosine, adjacent, -1. Hypotenuse 2. There we go. -1/2. Hard to get your brain in gear after a long weekend, isn't it? All right. Yeah, especially when it's nice out like that. All right, would you try this one? It's a lot like it, but this time I don't want to help you so much. This is like R2 level stuff, folks. You've got to be able to handle this or you're not even going to get a C on the test. So first thing you're trying to do is draw a circle and then figure out where the angle is. I want that eventually. Just put it away for now. Because I really want you to stay on top of the lesson. So in the long run, this test matters a lot. The last test of this quarter. Pretty confident that the graphing number 5 test, the last thing before spring break, will go on next quarter, not this quarter. Because it's so close to the end of break and so many kids are not going to be there on the day of the test. A lot of them will either take it early or they'll take it late, and it's just going to be such a mess if we don't push that to next semester. So the test coming on Wednesday is probably your last test of this quarter. Plus, just a note on the side here, last day to turn in late work is this Friday. Okay, so that's 3 days before the end of the quarter. Usually teachers pick a day before the end that they say is the last day for late work. Mine is Friday. No exceptions, even if you're sick on Friday. So make sure if you have late work, you get it in as soon as you can. Yes, sir.
2 questions. Question 1 is if you want to retake this coming test, you know, if we have that retake left.
I understand. You'd have to have it done by Friday.
It's Friday?
This Friday. That is correct.
And
So basically, if you bomb the test on Wednesday, you'd want to come in on Thursday and get your retake. It's like checks figured out. Make sure you get your homework done. I'm going to be grading homework either today or tomorrow. And then last thing is you could take the test itself on Friday morning. Okay, it can be done. It's a short timeline, but this is the end of the quarter, so everything gets squished. So how about you just plan on doing a good job on the test in the first place? That's a lot easier. It is. It really is. Because you'll end up having to do the same amount of work, and then you spread out at getting crunched at the very end of the semester. Overlaps with new stuff I'm trying to teach you. It's much better if you just learn it right the first time. Okay, so here it is. You should have this thing drawn. All students take calc. And then you should ask yourself, where is secant negative? Probably a better question would be, where is cosine negative? Because cosine and secant go hand in hand, right? So where's cosine negative? Well, it can't be here, because cosine's positive there. And can't be there. So secant's negative in 2 different spots. It's either here or here. Okay? And I guess another way to think of it is, where is... Oh, wait a minute. You know what? I'm doing that wrong. That's not where secant's negative. If this was negative, I could do it that way. My bad. I should be thinking instead like this. Where is negative 3/4 pi? Here's negatives going this way, right? And where is 3/4 of a pi? It's almost a whole pi, so it's like over here. Do you get that? How many of you drew it right here? Raise your hand if you drew it right there. Good. And do you get the part about how I was saying it was negative, but it's not? This is the negative angle. The answer here is not necessarily negative. I don't know that, at least, because I don't know what these numbers are. That's what I'm trying to figure out. Okay, so now back to this. If these are 3/4 of a pi, then this last part right here would be 1/4 of a pi, and I happen to know that that's 45 degrees. Otherwise, you'd have to go off the side of your paper and say, what the heck is 1/4 of a pi? And you'd have to times it by 180 over pi, and then you'd figure out eventually that it's 45. Okay. So, now, do I know my sides? Yes, I do, because 45 is one that I've got memorized. 1 square root of 2. So if I was going to find the secant of it, unless you've memorized sho, cha, cow, instead you probably would want to go back to, instead of doing secant, let's do cosine of this thing and then flip it. So what's the cosine of this thing? Adjacent over hypotenuse. And something felt wrong about this. What's wrong about it? Negative. That's a negative. That's a negative. Okay, so cosine is adjacent over hypotenuse would be -1 over root 2. But then to get secant, I got to flip that. So it's negative root 2 over 1. Yes, ma'am. Because this says negative here, I got to go like this direction. And that's where negative 3 pi over 4 is. And if this is 3 pi over 4, then this would be 1 pi over 4 left, which is 1/4 of a pi, which is 45 degrees. And that told me the sides were 1, and square root of 2. Then I got to remember that these two are negative because I'm in this quadrant, the third quadrant. And then I got to go find the cosine of it because that's the flip of secant. And then once I get that, I flip it over to get secant, and it's negative root 2 over 1. All right, moving on. Try this one last one. I want to warn you, this is not going to make a triangle. So if it doesn't make a triangle, it's one of those what do they call them again? Quadrantals. And so you'll have to remember how to do that. I'll show you in a second, but you should be able to do this. So if it's negative, right away I know my angle's going this way. That's 2 pi going to there, but I got to go farther, right? 3 pi. So I'm going to go all the way around another pi, and so there I am. Now I'm going to just go like this then. So here's my initial side, here's my terminal side. And how am I supposed to make a triangle for that? I can't. So instead you use the point, -1, 0. And then I know my sine of that is this, my cosine is that, and my tangent would be 0 over -1. Which one do I want? I want the sine, and so what's the answer? 0.
This is R2 level.
This is an R2 level, yes. All right. Now, I warned you this stuff is getting harder, and if you're not keeping up with the homework, then you're just asking for a C or a D on this test. Okay, and I know some of you aren't. I just know. So you're not going to be able to pull this off by just studying a little bit right before the test. You need the practice, and some of you guys seem really rough right now because these are things we've done for 4 days now. They should be able to be, you should be good at these. We've done 2 days worth of these. This is our 3rd day talking about this kind. See if you can draw me this picture. I'm not saying that you wouldn't make one little mistake. I've already made a mistake this hour, so You know, there's little mistakes that you can make, but if you have no clue what to do, you're not staying caught up. You're not doing your homework. You're not checking it with the answers. And you're saying, please give me a C for fourth quarter, if you're lucky. All right. So here's my fact that I know. The sign is negative. Now that's the kind where it's actually negative. The other one had the degree be negative. This one, the answer is negative. So where is the sign's answer going to be negative? Not there. All of them are positive. Students take calc. And it can't be there either because sign is positive over there. So where does sign come out negative? One of these two spots. But tangent's got to be positive, so it can't be here. It's got to be here where tangent is positive. So now, I don't know exactly what this thing looks like, but I'm just going to kind of draw myself a little triangle in there. And now I know the sine is the opposite over hypotenuse. That's like opposite, that's like hypotenuse. So the opposite from this central angle here would be -2. And the hypotenuse would be 5. So I'm getting close. Once you've got the triangle, you got to figure out your triangle and all sides in the triangle, and then you can continue. All right, so what's that other, yep, question? Okay, why can't tangent, okay, this part right here, when it says tangent is greater than 0, it's saying tangent is positive. Do you get all students take calc means where things are positive? Tangent is positive here, but we already ruled that one out. And tangent is positive here. That's why it had to be in that quadrant. Because by telling me tangent is positive, they're telling me it's either here or it's here. Yes. How about if I'd have said this at the beginning? Sine is negative. Get it? Because it's got a negative in there. And tangent is positive. Which quadrant am I in? Well, and you could say, okay, sine is negative means it can't be there, it can't be there. Tangent is positive means it has to be right there then. That's how I knew. Okay? All right. So now, oh, this other side. If this is 25 and that's 4, 25 minus the 4 would be 21. Do you get that's the square root of 21? Did any of you remember that it was actually negative? Because it's going that way. Oops, for some of you. All right, and then the final answer. Find the secant. They didn't ask me how many degrees it was. They asked me to find the secant. Well, to find the secant, I'm just going to find the cosine and then flip it. All right, cosine of this is adjacent over hypotenuse, which is -√21 over 5, and then I got to flip it. 5 over -√21, doesn't matter where the negative is, but there's your answer, come on, right there. 5 over -√21. Question? All right. Then, next kind. If I were asked what's the amplitude of this graph, it's 1. Do you notice that the total height from the trough to the top is actually 2? So when you're doing the amplitude, you take the total height and you do what? Divide it by 2. Another way to say it is the amplitude is from the middle line up and down. How high does it go? You know, it's like take the middle line and figure out the difference. But the easiest way is to just say, what's the highest it ever goes? What's the lowest it ever goes? Figure out the difference, and in this case that's 2. It'd be 1 minus -1. So the difference here, the total here is 2, and so the amplitude is half of that. I'm going to do a lot more with that when we get to the next test. But okay, so amplitude, formula for amplitude, question or comment? If the amplitude was a half, then yes, we would just cheat and change this to 1/2 and this to -1/2. It could have just been a mistake. I don't know the problem that you're talking about, but there was, I know, at least one mistake on the key. So, all right, so now, the formula. You have hopefully memorized this. A sine of, and a whole bunch of other junk. If you did not memorize it, look it up in your notes. But figure out, what is that formula again for the amplitude? A sine of blah, blah, blah. It's got a B and it's got an X, and don't say it, write it. I'm going to pause for a second and take attendance while you're doing that. Okay, so we're back from the little break there, and hopefully you put bx plus c plus d. Was anybody able to find that in their notes? Good. Okay, that's an important formula, because each of these little things has a meaning. That is, in the sinusoidal formula, that's the amplitude. That's how high it is from like here to here, divided by 2, notice. So if I told you this was like 8 feet, this was like 8 feet below sea level, the total distance between them is actually 16 feet. But the amplitude wouldn't be 16. It would be what? 8. It would be 8. Okay, so you take that and divide it by 2. All right. The next thing, that tells you the period, and there's a special period formula. Period equals 2 pi over b. Do you remember that one? Okay, so now if I want to change this thing's period and make either stretch it out or shrink it down, then the b number is important. Whatever it is, I just put it right there, and I take 2 pi and divide by that. All right, the next thing is the c, and that's the phase shift. That's where you take this whole graph and shift it. Like, for instance, if I shift it 1 pi, I go like that. See, I just phase shifted it over. Okay, and the last part is the D, that's the up and down shift. So I take this and I shift it up, usually. Or I could take it and shift it down, based on whether that D is positive or negative. All right, so now, let's focus on these phase shifts again. Why are they such goofy things? I remember when I first started teaching this, it struck me as strange that it wasn't like 2x minus 3. It was always 2x minus like pi over 3. Well, that's because this distance here, this is a shift to the right or the left, right? And the shifting right or left is happening on this axis, and that axis is labeled with pi's. It's in radians. Okay, so that's why these shifts are always like pi over 2 or whatever, because that's the way we measure on this. So if I did this one, do you get that if I were to look at how far I shifted it 2 pi, which means I'd shift it all the way over there. Do you get how it looks exactly the same, actually, if I do that? Because if I shift it 2 pi, if I like add 2 pi, do you remember the part where if you add 2 pi, it's like you didn't even do anything? You remember that? Because it's like going all the way around the circle and you're back to where you were in the first place. All right. Now, let's talk about a real problem that you're going to probably encounter. Here's a typical problem. It's a very simple one. It's just got cosine. And I've graphed cosine parent for you. I want you to sketch for me what that would look like if you shifted it over pi over 2. And hopefully you know which way that got shifted. I'm going to pause. Okay, here's what you should have done. You should have taken this graph, and I'm going to just redraw it, and then I'm going to grab it and shift it. Which way should I go, right or left? Left is correct. Okay, wait, get on top of that one, and then there. Left, how far? Pi over 2. How far is pi over 2? Like that. Raise your hand if yours looked like that. Okay, good. Now, what would have changed if I would have said, like, a 7 right in front of that? Yes, instead of going up to 1 and down to -1, this would be 7 and -7. You get that? And then what if I want the whole thing to flip by putting a negative like right there?
Flip those two numbers.
I'm trying to try that again. Say that's a -7. So I can barely see it. Then I'd take all these numbers and flip them. So whatever's high like this would go down low. And I would end up like that. Ugh, got ugly, but that's okay. All right. How to draw the parent with dots first. Ah, yes, that's just a reminder to myself that one of the best ways to do this kind of a graph is you start by graphing it, but you use dotted lines. Because the parent is usually not how it's going to end. Usually you end up flipping it or moving it, shifting it to the right or left. But it's always smart to graph the parent first. So everybody, please graph sign for me. Get a new fresh graph and graph just sign. And now, if it's really sine of 3x, that means, I hope you're getting used to this by now, that the period has changed. Instead of being 2 pi, now it's 2 pi, what's the period formula? 2 pi over what? Over b. What's b? 3, so it's 2 pi over 3. So this period is no longer 2 pi. It's 2 pi over 3. Then see if you can renumber these. This is half of 2 pi over 3, and then half of that goes here. See if you can number your axis. This combines all these skills together. Like, you got to be decent at fractions. You got to be able to just handle the fact that there's a pi in your answer and leave it there without changing it to 3.14. Got to have a little bit of spatial sense like you learned in geometry. All right. What's half of 2 pi over 3? 1 pi over 3. Do you get that? Half of 2 pi over 3 is 1 pi over 3. What's half of pi over 3? Well, think of it this way. Would you get that that's the same as 2 pi over 6? Pi over 3 would be the same as 2 pi over 6, right? So then what's half of that? 1 pi over 6. So half of pi over 3 is pi over 6. And then if this is 1 pi over 6 and this is 2 pi over 6, what's that? 3 pi over 6. Also known as pi over 2 if you wanted to reduce it. So there, I've got my new labels for my x-axis. Okay? They'll never be that easy if it's an R3. They'd probably have another thing at least. Like, let's say they throw a negative out front. Then you have to take the whole graph and flip it. So now it's going to go down and back up and then back down again. So there. And now maybe they might make it an 8 in here. And then you'll have to say that this is now 8 and this is now negative 8.
No matter what you do it to it on the outside,
Nope. The only thing that affects these guys is that number right there. And if I move the whole graph to the right, that would be a phase shift. That'd be like, let's say I did a minus pi over 2. Then I'd have to take the whole thing and move it to the right pi over 2. That'd be kind of a pain in this context because pi over 2 is hard to find. Well, there it is. This is really pi over 2. So I have to shift it that far from here to here. Yes?
So when you have a negative number out front,
Yep.
can flip it like you did, but can you also then switch the labels instead?
We don't want to call this negative 8 and this positive 8, even though I understand what you're saying. It's better to just, it's not that hard to flip a graph. You just make it the complete mirror of what it is. So we prefer that you not do that on these numbers. So just, yeah, when you have a negative out in front, just flip the whole graph like I did in green here. Okay, moving on. Try that one. The 2 is your B. And I want to make this a pi over 2 shift because it'll actually be easier. Okay, back from the little break that kids were trying to graph this thing. Here's the parent of it. Do you get that would be the parent? Then, do you get that this 2 changes the period? So it's period equals 2 pi over 2, which is the same as pi. So now the period is pi. So now I got to renumber this. This isn't 2 pi anymore. What is it? It's pi. And then this would be half of a pi. And this would be pi over 4. And this would be 1/4, 2/4. This would be 3/4 pi. 3/4 pi. Okay. Then I have to take into account the whole thing has to be shifted now to the left, pi over 2. So I'm going to do what I can do on a smartboard, which is I draw the original and I just grab it and I shift the whole thing to the left, pi over 2, which is the distance from 0, from like here to here. Okay, so I'm going to shift it that far. So here we go. There we go. Now isn't it interesting? It's the exact same thing as if you had flipped it up down. So a phase shift can act just like a reflection. Raise your hand if you got that. Good. Good. This must be my smart class. All right. This will take a little analyzing, but it's really good to get this vernacular down. I've been pounding since the very beginning that you need to know what initial and terminal side meant. This was the initial side. Terminal side is wherever you stop. Like, let's say you stop there, and you have a point XY there. That kind of a thing. What can you say about the point XY if it's on the terminal side of the angle? If, and then this is important, by telling me that sine is positive and tangent is negative, didn't they tell me where the point is? They did. They told me at least what quadrant it's in. So where is sine positive? Here and here. All students take calc. And where is tangent negative? Here and here. See where it got double circled? So I must be up in here somewhere. So now, the question is, now that I've figured out where it is, the question is, what can you say about x and y?
X is a negative.
X is a negative, very good. What else? What could you say about y?
Y is positive.
Y is positive. And how about, this is kind of a curveball, what if they said, what do you know about cosine? Well, if I'm in this quadrant, we know about cosine. What's cosine? Cosine is negative. And it's also the x, which is less than 0 or negative. If you figure out cosine, you could figure out secant, yes. Cotangent, yeah, you could figure out all of them. All right. What if they asked me about tangent? Well, they gave me tangent. But what's tangent made up of?
Y over X.
So what could you say about y over x? Is less than 0, yep. And that means one of these is negative, one of them is positive, so when I divide them, that'll be negative. All right, moving on. Where is cosine equal to the square root of 2 over 2? Cosine is the x, right? Do you get that that's a spot? And do you get how it would be really easy to forget about that spot right there? Because that's also another spot where cosine is root 2 over 2. How can you do something like this? Well, then you got to ask yourself, whenever they're telling you this, they're telling you whether it's positive or negative too. Didn't they say that cosine was positive by saying what they said? So then you should have said, okay, if cosine's positive, it's either here or here. And that would remind you there's two answers. You get what I'm saying? How about on the next one? Where is tangent equal to 0? Tangent equaling 0 implies that it's 0 over something. It doesn't even matter what. So one of the sides has to be 0. Where is there triangles that have sides of 0? Yeah, these spots. And at which of them is tangent actually equal to 0? Remember what tangent is? It's y over x. So If I go y over x, that's 0 divided by -1. That works. It's one of them. Where's the other one? Yep. So 0 and 180. Need two answers. Why isn't this one 0? Because it's dividing by 0, and that's undefined. It's not 0. All right. Almost done here. Last slide. All right, so if we have sine of pi over 2, do you get how this answer right here is 1? Do you get how if I add 8 pi in there, that's doing absolutely nothing? Because it's going to go around the circle a whole bunch of times, and it's going to end up in the same exact spot. Because that's a whole bunch of 2 pi's, so that does nothing. So what's the answer? Still 1. And this one, do you get that that's not just a whole bunch of 2 pi's, it's got 1 left over. So that's just pi. So then it's sine of 1/2 pi, that's what that is, plus 1 whole pi, which would be 1.5 pi. And what's the way that we usually write that? 3 pi over 2. So what is the sine of 3 pi over 2? It's right there, -1. And the last one, 39 pi is one of those odd ones, so there's a leftover pi. All the 2 pi's cancel out, and we still have a leftover pi. And what's pi plus pi? And what's 2 pi equal to? Not 1. 2 pi is the same as 0. Get it on this circle here. If I'm at 0 degrees, or if I go around 2 pi, I'm at the same exact spot. So that's basically asking me what's the sine of 0. And what is the sine of 0? It's right there. If you really want to go find the sine of 2 pi, go ahead. It's the same thing. 0. Okay. So, your test is coming. Not tomorrow, but the next day. And I know you probably don't feel completely ready for that. Well, I got a solution for that. Do your homework. Check it. Make sure you're understanding it. Come back tomorrow with any questions that you have. Then do that homework, and then check that homework. A lot of you guys have not been rising to that challenge. Now, if you have been, then just ignore me. I'm not talking to you. But if you're one of the kids that's like not been doing your homework, I'm telling you, unless you want C's for the rest of the semester, you have to do that stuff. You won't be able to get this just by trying hard in class. You have to try hard in class and try hard at home. This is where this class gets hard. And either you change what you're doing, or when the material gets harder, you're going to get a lower grade. But if the material gets harder and you try harder, then you can keep your higher grade. And then it's up to you.